I'm Ajitha, Assistant Professor in the Department of ECE, working at Institute of Aeronautical Engineering. So today I'm here to give a brief introduction about information theory. So what is information theory and what is exactly information? So before going to information theory, let us have a slight look on communication system, because this information theory mainly related for an ECE department for communication system. Okay, so what is a communication? The communication system is to carry information varying from one place to another place through a channel. So in the communication system, what is main important is information. So what is an information? Information is a data which is classified data which have some meaningful values for the receiver. So here, what types of informations are there in real time? So for example, speech signal is there, a man speaking signal, other speech signal. And we are transmitting images from one place to another place, photographs. So that is also information. And motion of films, nothing but video. So video is nothing but a motion of images. So nothing but frames. So these are some examples of information signals. Now let us have one example here. Suppose I'm recording a video. So this video consists of both video information as well as audio information. So here information is my YouTube video. So what we have to know here is, so this has to store in the computer and it has to transmit from one place to another place. Here comes the concept of information theory. Okay, information theory study show how much sequence of symbols or signals can be most effectively encoded and transmitted. So this is very important in the information theory, how the information is effectively encoded for transmission. That means if my video as usual, if stores in the computer, how much memory it will occupy? That is the basic question arises. So it should be effectively encoded. That means it has to reduce its size. The video has to reduce its size. So we are going to discuss about how effectively encoding is done for information, and it is transmitted through media. Okay, that is information theory. So it is mainly concentrated on fundamental limits of communication system. So what are the fundamental limits? As I told, my video signal, if I reduce storage, reduce the memory means it is a loss of information. So how much I can reduce memory? So there is some limit is there. So information theory provides that fundamental limits for the communication system. So this is very important for information theory and communication system. As usual, communication system, we cannot be used in real-time system. So compulsory we have to apply information theory on the communication system. Next, so what is the purpose of information theory? So as I told earlier, we have minimum time and space. What is the meaning of minimum time and space? So my video has to occupy less storage. So less storage, and it has to transmit from one place to another place in a minimum time. So if you download video also, it has to require less time. If it takes more time, then it is not an efficient way of transmission. Okay, so for efficient way of transmission, so these are the main aims of information theory. So that is the aim is to reduce the time required to transmission and space required for storing of the information. So next question, why we need to study the information theory? So this is the as usual question. Nowadays, communication is in a revolution process. That means you are seeing 4G communication and 5G communication also. So it is revolution. Communication is in a revolution manner. So all the hardware we need to support for software. So all the transmission information and its transmission becomes necessary requirement for an engineer. So that's why we are going to know something about this information theory when we are designing the communication system. So what is this information theory related to other fields? Suppose if you take, this is our communication theory. So this communication theory is part of information theory. And you have one more block is there here. Probability theory is also there. So probability theory and information theory, we have a relation between probability theory and information theory. So that relation we will combine with in the analysis of the communication theory. So communication theory analysis, we will use probability theory also. So we have an excellent point here, computation versus communication. So what is computation and what is communication? So as we build larger computer out of smaller components, okay, we encounter both a computation limit and communication limit. Okay, in the communication limit, what is the meaning of communication limit? That's speed. So we have a limit on the speed, that means transmission speed in the communication. So we have computational hardware computational limits also there in the communication. That is, computation limits are controlled by communication and communication limits are controlled by computation. So this is very important point in the design of information theory. We have to see a balance between computation limit and communication limit. Okay, this is about the brief introduction where information theory is applied for all the fields. In statistics also it is applied, in mathematics also it is applied, and economics also it is applied. So every field, information theory is an important field to analyze or to mathematically model the requirements. So this is the architecture of communication system. So as we know, before learning information theory, we must know communication system, because in the design of communication system, we are using information theory. So information system, if you observe, so this source to channel coder. So this is called your transmitter. So we are sending information from transmitter to receiver. So this is the receiver part. So inside the between transmitter and receiver, we have channel is there. This channel we know wired and wireless. Wired and wireless. So what is wired media and what is wireless media? So wired media means, as you see, optical fiber cable. So this is the example for wired transmission, and wireless transmission, free space. Free space. So all mobile communication, all use free space as a channel. So in the transmitter, what will happen? So in the transmitter, first block in the transmitter is a source. So what is the use of source? So as I said earlier, I am delivering a speech signal. So this speech signal contains English alphabets. So it has to convert into bits, because our computers understand bits only. So it has done, so physical information is converted into bits. So that is the task of source. You can observe source as any source of information. We can observe source as any source of information. That means you can transmit speech signal, video signal, audio signal. It may be any source of information. Then after getting bits, if I as usual transmit, it will takes more space and it is unable to transmit as usual. So here I am going to apply source coding technique. In the transmitter itself, it is going to apply source coding technique. That is, change to an efficient way of representation. Okay, so our bits are converted into efficient way of representation. That is data compression. So we are using source coding in our real time also. I will tell an example. When your file is saving as WinRAR, you are saving our WinZip or WinRAR, you are storing as a compression. Okay, so this is known as one compression technique. So it is called as lossless compression. Lossless means here we are not missing any data, but we are reducing the size of files. Okay, and you have one more compression is there in image. You are storing as JPEG. So this is also an image compression. So without knowing compression, we are using in our real-time applications. So that is WinZip and WinRAR and JPEG. So what is the use of source coder? Source coder is used to apply efficient way of representation of data, that is data compression. After data compression, we are going for channel coding. Why we are going for channel coding is, in the transmission, so we are transmitting through channels. So channel, there is chance of adding noise in the channel. So this noise is an unknown signal which corrupts our original data. So to provide an error protection from the noise, we are going to use channel coding technique. So what is this channel coding technique functions? If you observe this block, this is an efficient representation for transmission. Okay, this is an efficient representation for data source coding, and channel coding is efficient representation for transmission. That is, we are providing error control coding. Error control coding means error correction and detection. Suppose in the transmission of data, suppose I transmitted 1001 through the channel, but it is corrupted 1010. Okay, so data is corrupted by noise. So how can I detect that errors is? I will use channel coding. So I will provide some error correction and protection to the data. So by using parity bits. So I will use extra information for the channel coding. By using that extra information, we are going to predict errors in the channel. So that is the use of channel coder. So in the source coding, we are going to provide compression. That means efficient way of representation of information. After efficient way of representation, I am transmitting through channel. But there is a disadvantage in the channel. In the channel, what is an extra component added in the channel? The extra component added in the channel is noise. So to protect the information from the noise, we are using channel codes. In the channel codes, we are using parity bits as an extra information to provide error correction and detection. After error correction is recovered, then we are having, this is receiver. In the receiver, again we are having reverse process. We are having channel decoder. So channel decoder means wherever we got the errors, we want to recover those errors. So that is the task of channel decoder. This is recovered from channel distortion. If any noise is added and information is distorted, that is recovered by channel decoder. So that is the function of channel decoder. After channel decoder, we have source decoder. So what happens in the source encoder? We reduce the size of the information. So that same thing is uncompressed. Here compression is applied in source encoder. So reverse process at the source decoder, we are going to apply uncompress. And after the uncompress, we are going to receive the information as usual. Because all these steps happening in the real time without knowing to us, because all we are using information daily life. So all these steps are happening in the daily transmission. Okay, source coding is happening. Examples for source coding, as I told, WinRAR and WinZip and JPEG are some algorithms for source coding technique, and channel coding techniques also applied. Example, if a satellite is sending an information from its location to Earth station, so you can observe how can distance it has to travel. In the transmission, there may be a corruption of data. So channel codes compulsory applied for some communications like satellite communication. So this is a brief introduction about the communication system. So in the next slide, we are having some parameters in the design of communication system. The parameters are, so source coding and channel coding. These are the main important steps in the communication system. So the main important parameters for a communication system are H, R, C. So what is H and what is R and what is C? Here H is an entropy of a communication system. As I told, here physical information is converted into bits. Physical information is converted into bits. So what is the information present in the source we need to analyze? So that should be converted into bits. So there is some limit on H. There is some limit on the H. So H is known as information content in the source. This is also called entropy. So in the coming lectures, we will going to see this entropy. So entropy is information content of the source. So we are having source. Source information is converted into bits. In the bits, how many bits are necessary to represent our information, that we need to calculate in the H. So there is some limit on the H value. So it should not be maximum. It should be minimum only. Then after H, source coder will reduce size. So H is converted into R. So on what we can do this R? So the R is having also some limit. What is R? Rate from the info source coder. Rate from the source coder. So here lossy. Compression is a lossy. So we are applying compression in source coding technique. Lossy means what? Lossy means we are losing the information. So at what extent we can lose? At what extent we can lose? That is the main point which decides the value of R, rate of the source encoder. And channel coder, so we are transmitting to channel, So channel having a parameter called channel capacity. So what is channel capacity? So how much data we can transmit through the channel? So at what extent it can accommodate? So here R, H is converted into R from the source coder and R is converted into C. So C should be greater than R. C can accommodate total information. So that there is some limits on HRC.
హెచ్ఆర్సీ గుర్తుపెట్టుకోండి. మొత్తం ఈ ఊరే చూస్తారా? ఈ ఊరు చూడరా? ఏం కాలే, ఫస్ట్ క్లాసే కదా. అప్పుడప్పుడు ఇప్పుడు ఇక్కడ పని చేయనప్పుడు గీడ చూడండి, అర్థమైంది కదా. దీంతో పని లేదు కానీ మీరు ఎక్స్ప్లెయిన్ చేయగలుగుతారు కదా. అప్పుడు ఈయన చూడండి. వద్దు, కండిషన్ నో ప్రాబ్లం. మీరు ఎక్కడైతే బోర్డుతో మీకు పని ఉండదో, మీకు బోర్డు ఎప్పుడైతే పని ఉండదో అప్పుడు
చెప్పాను. ఇప్పుడు
ఎక్కువనే చెప్పారు, ఎక్కడైనా చేశారు. అవును, గుర్తుపెట్టుకోండి మ్యామ్. బోర్డుతో పని ఉన్నప్పుడు ఎక్స్ప్లెయిన్ చేస్తుంటారు. అప్పుడు దీని చూడండి, ఈడే అబ్బాయి అనుకోండి. ఓకేనా?
స్టార్ట్
అక్కడ నుంచి చెప్పండి. ఆర్సీలో చెప్పారు కదా, ఆర్సీ అక్కడ నుంచి స్టార్ట్.
C is called channel capacity. So here this is having also some limits. All limits are decided by the course called information theory. So why now you can understand the clear idea of information theory. This will give the fundamental limits for H, R, C for the efficient way of representation of data and the transmitting of the data from transmitter to receiver. So before we are having two terms, the main important terms in the communication: source coding and channel coding. So what is the goal of source coding? The source coding goal is it has to reduce the bandwidth, it has to reduce the memory store. So two are goals for the source coding. It has to reduce the bandwidth, it has to reduce the memory to store. So in the process we are doing compression. So what is the meaning of compression? What is the meaning of compression? A simple point I can tell you now, the compression is nothing but elimination of redundancy in data. Suppose in my speech signal only, if I speak 2 times is, it is a redundancy. It is called redundancy of the data. So that redundancies are eliminated in the sending of the some information in the fewer bits. So main important in the compression is to remove redundancies in the data. Next, what is channel coding? Channel coding is detect and correct the errors in signals to improve. The main important parameter for channel is bit error rates. What is bit error rate? So it mainly reduces the bit errors present in the data. Next, what is source coding theorem? It has to follow source coding theorem. So as I told earlier, fundamental limits on the error-free communication is given by information theory. So we are having so many channels, reliable channels and unreliable channels. So mainly we have to focus on the channel also because it affects the information. So based on the characteristics of the channel, the information gets affected. So error is introduced in the channel, error is introduced in the compression as well as in the channel itself. So error is introduced in the compression, which is allowed by D. So that is known as the problem in the known as rate distortion theory. As I told, if we compress the data, so we are having data, so we reduce the size of the data, but what happens here? It is going to affect quality. Okay, when we reduce the data size, it is going to affect the quality. So there is a balance between size and quality. That is known as rate distortion theory. So how much distortion you are providing for the data. So at what rate we are providing and how much of quality we are losing. So that is a theorem called rate distortion theory, which provides limits between data size and quality. And what is channel capacity? So here we are having channel capacity. So every channel is having its own capacity. It is the upper bound on the rate at which the information is transmitted. Okay. So now we are going from 4G to 5G. We are going to increase a channel capacity because in 4G we cannot transmit videos. Okay. It takes more time to download also. If we increase the channel capacity, automatically it will take less time to transmit. So channel capacity is the upper bound of the communication channel for which it can transmit the symbols. And the channel coding theorem is also there. So we should have a balance between quality and size. Like this, there is a balance between the data in channel coding theorem also. In channel coding theorem, we are going to add bits. So bits we are adding. In source coding theorem, we are removing the bits. Here, adding the bits means again we are providing the information, extra information. So we have to balance how much extra information necessary to provide error correction and detection. So these balances we should take care in the design of communication system. Okay. Next, in the design of communication system, we have term uncertainty. Okay, what is uncertainty? And let us look at two examples on discussion of this uncertainty. Uncertainty information. So this information, if we reduce the uncertainty, it is known as information. How to reduce the uncertainty? So we have, when speaking some words, some are likely and some are unlikely. If you observe two statements, the sun rose this morning. This is very not an informative because it is daily happening. So it is not informative. If we go for solar eclipse in the morning. So observe these two statements, which is more informative, which is not informative. So first one, as usual, daily happening. So this is not an informative, which does not contain more information. But second statement, it contains more information. Solar eclipse in this morning. So there is certainty and uncertainty. If you observe two lines, this is certain. This is certain. But this is uncertain. Okay. So we have to reduce the uncertainty in the data. Then it is called as a perfect information. That is what happening in the source coding. In the source coding, we are going to reduce the uncertainty. So that means we are going to increase the certainty of the statements. So let us have a look into this two statements. So first contains a low information content and second contained high information content. Suppose I want to transmit the two statements from the transmitter to receiver. First I will transmit solar eclipse in this morning because I need to send this information to the receiver because the first statement does not require receiver because receiver also know this statement daily it is happening. Okay. So it is the highest information is always transmitted from transmitted to the receiver. That is the basic idea in the source coding. What is the basic idea? Which is having highest information that should be transmitted transmitted to the receiver. And we have independent events which have additive information. Independent to means, so this statement and this statement there is no relation. Suppose this statement and this statement is having some relation, then I need to use this statement for the transmission of this statement. So somewhat I need to reduce in the transmission process. This is what happening in the source coding theorem. Suppose we have a tossing a coin experiment is there. It has some data, but if I want to transmit twice the coin tossed, if I want to transmit twice the coin I tossed, so which will take more time and more space. Obviously, the second case will take more time and space. Okay. So first will take less space and less time, but second take more time and more space. So how I'm here to give some examples on uncertainty also. So as I know what is uncertain, if it is not, if it is what is certain and what is uncertain. If we have a doubt, that is called uncertain. If we have a no doubt, that is called certain. Let us have first example. Suppose I am asking about prime numbers less than 10. You can give the answers 2, 3, 5, 7 as the answers. Okay, but you can't say single digit. You can say 4 digits are there. In my mind 2 is there, another mind 3 is there, but uncertainty is 4. Uncertainty is 4. So it is some doubt is there in the mind about the answer. Okay, so this is called the uncertainty. And if I give 3-letter word C dash T, immediately someone give answer CAT and someone give COT, CUT. So answer is not single answer. There are few answers. So uncertainty is 3. This may vary also. This may vary. Based on the vocabulary, this may vary. Okay. Now you can answer the uncertainty. Suppose the third example, P is a prime number less than 10 power 100. P is a prime number less than 10 power 100. So what is the uncertainty here? Uncertainty we can't guess because the data size is more here. Okay. So possibilities are large. Even answers vary from human to human. It's all depends on the computational capabilities of humans. Okay. So more numbers are there for the answers. So someone give 10 numbers, 20 numbers. It depends on the computational capabilities. So there is certainty and uncertainty. Certainty means fixed answer. Uncertainty, a guess. A guess and some disturbance in the mind. So it is uncertainty. So information theory, some points about this uncertainty is, so this information theory to represent extreme points of all communication schemes. So it will provide all extreme points for the communication scheme based on removing of this uncertainty. If you remove the uncertainty, it is converted into information. So that's what information theory. If you come for information uncertainty, let us look at first point A. Uncertainty can vary based on the knowledge and belief. Okay, as I told here, vocabulary. This varies from vocabulary knowledge. So uncertainty is no fixed, not fixed. It varies based on the human knowledge and human belief. And second point, all elements in a guess list may not be equally likely. So may not be equally likely. What is the meaning of equally likely? Suppose a coin is tossed. What is the outcomes? Outcomes is head and tail. So these are equally likely. Equally likely means head is possibility 1 by 2 and tail is 1 by 2. But all elements in the guess need not equally likely. Okay. So that is the main important point for certainty. And third one is there may be a notation of accuracy up to which may not distinguish guesses. So we can't predict the full guesses also. If data is like 10 power 100, third example, prime number less than 10 power 100. So here uncertainty is more. So to remove this uncertainty, information theory uses the probability theory. Okay. So probability theory is a mathematical framework for representing uncertain statements. See, everything is interlinked here. I'm telling here communication system. Communication system is interlinked because here we need to design HRC for every communication system. So it uses information theory. Information theory. In information we have uncertainty. We have uncertainty. This uncertainty is removed by probability theory. So every field is linked up here. Probability theory is linked with information theory linked with the communication theory. So what is probability theory? A first line very good statement, mathematical framework for representing uncertain statements. This probability is used for the study the behavior of the randomness. Okay, random because information is random. So we can't predict the next what information is coming from the source. It is a random. So to model that random waveform or random signal, we use probability and for representing the uncertainty statements. It provides the mean of quantifying the uncertainty. So we know the probability of event is likelihood of event occurring. Okay. Suppose probability of compulsory happens, sun rises in the east. What is the statement of that probability? The probability of that statement is 1 because it will happen every day. So the probability value always lies between 0 and 1. If compulsory happens, it takes 1. If it is not happen, impossible. If that event is impossible, the probability is 0. So these based on the probability value, the information also we will guess. The information takes the probability 0 or probability 1. Earlier examples like sun rises, so it will take the probability 1. Next statement, it will take the probability between 0 and 1. Based on the probability value, we are going to transmit the information. So this plays an important role in the analyzation of communication system to provide the limits for the communication system. Okay, certain means 100% chance, so probability is 1. Impossible, it should not happen, then probability is 0. So this is about small introduction about information theory. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.